Let's create a game of tic-tac-toe. So we always start with a field, a 3x3 field in which you can place, in which a player can put X or O. Now in this case I've numbered the positions because that's easy with keyboard input to place your position. So let's output the fields. You can do that like this. So that would output the first value. If you run it, you'll see the first value, and we can do that for the whole field. So that will output our whole playing field. So there we go, we've got our playing field. Then we want to ask the user where it wants to place it, where it wants to check, right? In which position. So where to place, right? So we need to store that position. Now remember that if we ask for input, it outputs of the type string, and we need of the type integer. So convert it to an integer by calling int. Now it asks us where to place it, for example 9. And the next thing to do is to set change the playing field position. So in this case fields x minus 1, because we start counting from 0, is x. And then we want to draw the playing field again. So we'll be drawing the playing field many times. So why not turn that into a function, right? As parameter, it could take the field and say draw field. So now, for example, we place it in position 9, and you'll see we placed it in the right bottom corner. Now you want to repeat that process. So, for example, while true, and then put 4 spaces in front of the whole process. And in order to make it a bit easier to read, we print a new line here. So now if we run it, might want to draw the first field as well. Enlarge it a bit. If we run it, you'll see it asks us where to place it, for example 1, then in position 2, then in position 5. And you'll see that wherever I answer where to place it, it places it. Now in the game of tic-tac-toe, there's always 2 players. And in this case, there's only one, which is always pressing the X. So those need to change. So we have 2 players, so we can have a current player variable. Current player is 1. So if current player is equal to 1, we put that symbol. Otherwise, we put the O symbol. And of course, the players need to switch. So current player is 0 and current player is 1. So now it iterates players. So we can say, for example, 6. Now the other player is playing. So for example 3. And you'll see both players are playing O and X. So you see it switches player. And you might also want to output that, so we can use an f string and output the current player. So now it asks us where to place player 1 and player 0, where should it place? Player 0 turn again, or sorry, player 1 turn again, maybe in position 6. And you see that we can now, you might want to output in front. And perhaps you want to remove the new line. So it's a bit of too much, but a new line here. Okay, so where to place? The other player's turn. Player 1 turn again. Now it's player 0 turn again. And of course player 1 would then place it in position 3. However, now we have a line here. So the game should finish because obviously this player won. However, in the current game it just goes on indefinitely. Currently the game never ends, right? The people can place their position. Example, position 1, position 2, 3, 4, 5. But no matter how many times we, or if we have, for example, a row here or a row here or a vertical row, the game never finishes. Now, in order to check the if the game finishes, it needs to check rules, right? So we can have a function called check with the fields that will check if the game is finished. And so we call that, and by default it's not finished. However, it can also be finished, for example, if 3 values create a row. So for example, if field 0 is x and field 1 is equal to x and field 2 is equal to x, then the game is finished, right? Perhaps you just want to exit when that happens. So if we run the game and we say 1, 2, and 3, you'll see x wins because we have 3 in a row. Now in this case it didn't output the last fields, so you might want to output the game before that happens. So if we run it again, 1, 2, and 3. So we'll have 3 in a row here in our check function, and that's why x wins. Now of course you want that for both players, so and you want that for all rows. So in order to do it for all rows, you can just copy that twice because there are 3 rows, right? And then just increase those numbers. So 3, 4, and 5, as well as 6, 7, and 8. Now, note that we repeat the code a lot, right? So what you might want to do is to have an endgame function where you have that code. If you have a lot of code or repeating code, you want to put that in a function, because that makes it easier to comprehend. Just like we did it in our loop here. We switch the player and then we check the rules and draw the board. And you'll see this code is repeated a lot, so that's not what you want. So you can copy this duplicate code into a new function. So that way we can call the function like this. And now you'll see, if we run the game, and for example, we make a row in the bottom, you'll see X wins because we have 3 in a bottom. So now any of the horizontal lines can be used. Now you can use the same principle for vertical lines. So if you copy that, there are 3 vertical lines, right? So the first, second, and third. Now that would be 0 and 3 and 6. As well as 1, 4, and 7. As well as 2, 5, and 8. Two, 5, and 8. So that way you can also have vertical lines. Now a diagonal line is also possible. So that would be 0, 4, and 8. Zero, 4, and 8. You see 0, 4, and 8 is a diagonal line, and the other diagonal line you can have is 2, 4, and 6. So in that way, there's multiple ways in which player X can win. For example, we can have 1, 4, 7, 4, and 7. You see we have a vertical line here, so X wins. We can have a diagonal line, which would be 1, 5, and 9. Now note that the other player is also playing, so that's why I'm putting some numbers for player 0. So 1, 5, and 9. And you'll see X has a diagonal line. Now this works for the other diagonal line as well. For example, 3, 5, and 7. So 3, 5, and 7, you'll see we have a line, a diagonal line. However, in our example, only player X can win. We can do it for both players, right? So we can loop over the players. The players are either X or O. And we can say for player and players, indent this whole block, and instead of X, we can have player there. So that way it checks for both X and O. And it's also possible to add yet another player. However, I never tried playing this game with more than 2 players, so I'm not sure that would work. But technically that's possible, right? You would just add another player in there. So you want to replace X here with the X with the player variable. And instead of just end game, it should know which player wins. So that's the player. Right? sorry. So add that parameter. That way, both player A and B can win, or in this case player X and O. So for example, let's make the other player win. And we create a line here, you'll see O wins. So both player X and O can now win, and we have the basic tic-tac-toe game. You see now X wins, we have a line. And theoretically you can add another player here, and you can clean up the code a bit. For example, now we have all these if statements here. What we can do as well is use OR. So if this, or if that, or if that. So you can say also else if or elif. So that's another way to write the code. Which is exactly the same, but it's a bit cleaner to read. So yeah, we have the tic-tac-toe game. We can run it and play it. So in this case, player X wins again. And you can download it and play around with the game logic yourself. Now in games you often have a game loop. In this case, this is our game loop, in which certain things are handled. For example, what we have here is the input. So we could have a function input, right? Where we put all that code. And we say get input. So we get the input. This is switching players. So we can have a function switch player. So call that as well. So now we have a very small code base, or very small game loop, and you always want to keep your code into as much tiny code blocks as possible, or as many small functions, because that makes it much easier to do the programming. If you have very large functions, then it becomes very difficult to comprehend. So in this case, it's trying to get the current player variable, which it doesn't know, as well as here. And that's because current player is a global variable. Now the current player variable is a global variable, which we defined here. So there are two ways that we can solve this. One is to access that global variable. So if we say in the functions global current player and global current player, we can access it. So you'll see we can play the game again. So that's one way to solve it, if we just reference it. Another way is to remove the global variable here and use a local variable in your loop, which you then pass as a parameter. And then of course you want to return the parameter and store it again. In this case, I'll just use the global variable because it's very easy to do it, and for the purpose of this game, it doesn't make any difference. So we have reduced the game logic a lot, and you'll see basically this is our game logic, which consists of several steps, and the functions are defined as here. Now you can try to make your own version of tic-tac-toe, or just download the code and play around with it.